right. So here we go. Let's start off with our content. I'm going to go right to frame 4 here. So frame 4, we are starting with function notation. Okay, so this is, notation is not solving anything. Notation is not a new type of problem. Notation is just the way that we write things in math. Okay, so before, up to this point, we've seen things like this. Y equals 4x minus 1. We're used to that. We feel comfortable. We have an x and a y. Today, we're going to see a different notation. And basically, instead of y, I'm going to write something we will refer to as f of x. Okay, so you guys may have seen this actually snuck in here and there in other units, but today we're really talking about it and we're really focusing on it because we're going to use this notation to help guide us through another part of this learning target. So again, the way that I would say this, and I'll write this down below here, the way that I would say this is f of x. Okay, and let's break down what the parts of this are. Okay, now this is literally the exact same thing. I haven't changed anything. F of x is the same as y. But here are its components. We have an f and an x in parentheses. What do each of those variables represent? The f is like the name of the function. So you could replace that f with, you know, a g, an h, a p, a q, a b, I don't know, any letter you want. That's going to be the name of the function. Just like you and I have names, functions also have names. This x, that is going to be the variable that you see in your equation. So if I look at my equation here, I have a 4x minus 1. This x tells me, hey, you're going to see an x in your equation. And what do you know? I have an x in my equation. So I say f of x because this is the most common function notation you're going to see, but it doesn't always have to be f of x. We could, instead of an f, you know, like I said, I could change the name of this function. I could have a g of x. Or I could change the name of this function again. Instead of a g, I could have an h of x. I haven't changed anything. I've just changed the name of that function. Instead of naming it f, I'm naming it h. It's the same thing. I'm going to keep it f, though. The other thing we could change is I could change this x in parentheses. Oh, didn't mean to do that. I could change this x in parentheses. So remember, we said x means that's the variable you're going to see. So if I change that variable in parentheses, let's say I make this an n, that just means the variable I'm going to use in my equation would have to be an n. So there are lots of different combinations that we can use with this function notation. But like I said, most of the time, you're going to see f of x. That is the most common way that you'll say it. And if we were in class, I'd make you all repeat after me so you get used to saying it this way. F of x, the name, those parentheses are of, and then whatever's in the middle. So we would say, you know, g of n, h of q, whatever those variables are. Okay, now let's talk about, we had some notes to add in there for what each part was. So here we have f of x is the input value. So remember, input is like what you have in the function. So here you can see we put x in the function. And then that would mean f of x is the output. Now, previously, we said y was all of our output values. Well, guess what? F of x and y are the same thing. Just like I said, we haven't changed anything. I've just changed the name of my function. And I reiterated that here with this silly meme. We have, these are the exact same thing. One of them is just a little bit fancier. All right, so let's get a scale of 1 to 5. 1 being, I don't get notation. Explain it one more time. 5 being, yeah, I think I get the notation part. Tell me in the chat where you're at. 1 to 5. And I would love to hear from everyone. 1 to 5, where you at? Just the notation. I haven't solved anything yet, just talking about the naming of our functions. All right, I see a couple 3s, so I'm just going to do a quick recap real quick before we move on. Those of you that haven't responded or maybe just don't want to say what number you're at, tune in here so you can follow along with me. So again, we are just rewriting the same exact thing. The only thing I've changed here is that I've changed my y to an f of x. And I say f of x. That's how we say it. F is the name of your function. So again, I could change the name. I could change it to a G. I could change it to an H. This doesn't matter, really. It's just the name. Okay, just like you and I have names, we all have different names. We're all still people. It's not a big thing. I thought the poo meme was good. And then x, that's what variable you see in your equation. So here, because we see an x in our equation, I have an x in parentheses. If there was, let's say, I don't know, a q, I would put a q in parentheses and I would say f of q. And all that means, again, is that f is the name of our function and q is the variable that we see in it. Okay? Now I'm going to keep it as f of x because, like I said, that's the most common one. All right. Hopefully with that recap, we are all caught up. So I am going to move on. This is function notation. Now that we've seen the notation, we need to be able to evaluate using this notation. So here we go. Let me read through our problem. It says, function notation is especially useful. Oops, what in the world? Function notation is especially useful for finding a value in the range that corresponds to a certain domain value. All right, and then it wants me to find f of -7. Okay, now this all sounds super scary. Let me break it down a little bit more for you. Basically, we're going to find f of -7. Remember, wherever I had when I had an x in parentheses here, that meant I was going to see an x in my equation. I still have my f here. That means I'm using this function. The only thing that's changed, and now instead of x, I'm going to see -7 in my parentheses. So let me write that out a little bit for you guys if you are taking notes like you should be. So if we have f of x, that means we have x in the equation. If I have f of -7, I no longer have any x's. I'm not going to see an x in my equation. Instead, you will have -7 where all the x's were. I'm literally replacing, just like I did here, my x with a -7. So in my equation, I'm going to replace this x with a -7. So here we go. Tune in. I'm going to rewrite my function. So originally, my function was 4x minus 1, but I no longer want this x. Instead, just like I said, we're going to replace that x with a -7. And you'll notice, what did I put around that -7? What did I put around our -7? What did I put around -7 here? That's super important that we use when we're substituting. What did I put around the -7 when I substituted? It's really important that I use it every time I substitute.
Parentheses.
Thank you, Monty. Lexi, is that what you were going to say?
Yeah.
Are we just writing P because we didn't know how to spell parentheses? Yeah, okay. Got it. That is a hard word. I'll give you that. So here, whenever you are substituting something in, I'm going to make a little note at the top that we always use parentheses, okay, when we're substituting in a value. So now my job, because now before I couldn't simplify anything because I had an x, now because I have all numbers, I can actually get one value that correlates with this -7. So here I'm going to use PEMDAS. Okay. Now, parentheses means that there are multiple things inside the parentheses that I can combine together. I do not have that. I just have one thing in parentheses. So I am not going to use, I'm not going to go with parentheses. E stands for exponents. I don't have any exponents here, so I'm not going to do that. M stands for multiplication. When I have two numbers right next to parentheses, that means that I am multiplying. So I'm going to do that next. So I'm now going to have f of -7 equals 4 times -7 is -28 minus 1. So going back to my PEMDAS, I've now multiplied. I don't see any division here, so I'm going to skip that. I don't see any addition, so I'm going to skip that as well. I do see subtraction though, so I am going to subtract those two numbers. Negative 28 minus 1 gives me, oh, I was using a different color. F of negative 7 equals negative 28 minus 1, which is negative 29. And voila, I have my answer. And you're going to write your answer this way. You're going to write it out with the function notation. So you'll say F of negative 7 equals, and then whatever you get. So let's recap, because all of this looks very intimidating, but really when we break it down at the core of it, guys, what we're doing is I'm taking my function, and anytime I see a variable, I'm replacing it with whatever number was in parentheses, and then we're just simplifying. That's all we're doing. And if simplifying is proven to be difficult for you, you have a calculator that you have access to. If you don't have a calculator right on your desk, remember on all of your Chromebooks, there is that calculator app that was preloaded for you. Also, most of your phones have calculators, so you could always use that as well. All right, I'm going to pause in case there are any questions, because in a moment, you guys are going to try it on your own. And then I'll be calling on people. Just in case there are any questions, you can raise your hand or throw it in the chat. Which part, Lexi? Is there a specific part?
For like when we go to like our homework assignments, are we gonna have to write all of this down on like our paper? Like f of x, have x in the equation, and then all of that?
Yeah, so these problems are one that you will want to write out a lot of work for. So like on an assessment, this would be one that you'll have to write out work for. Basically, I need to see two things. I need to see, if you're, a person that hates showing work, I need to see this step where I saw you plug in the value for x, and then I need to have your final answer written like this. Of course, I would love to see those steps in between, because that's going to help you simplify a little bit more. But I really need to know that you understand that we're just substituting in negative 7 for x, and that you know how to write your answer the proper way. Does that help, Lexi?
Yeah, thank you.
Mm-hmm. All right, so I'm going to go on to this next frame. If you're on the Jamboard, I'm on frame 6. I want you guys to try this on your own. So for this first one, I want you to try both. For the first one, you're finding f of 5. For the second one, you're finding g of negative 3. Remember, don't get confused by the g. That's just the name of the function. That hasn't changed what we've been doing. So you're finding f of 5 here, g of negative 3 here. I'm going to give you guys about a minute to go through, and then I'll be calling on some people for answers. It's just random. All right, I'm going to name some people that I want to help me out with this. So I'm going to pick on Jesse for number 1. And then I want Monty to help me out with number 2. All right, Jesse, you trash my music, you get called on. So Jesse, if you could unmute, that'd be awesome. But at the very least, explain to me in the chat what I did here or what your final answer was. That's okay, Jesse. So let's do this together. Let me go back to our other frame. When I had f of -7, I took my equation and I plugged in -7 for our x. So let's look at this new one. Here I want to find f of 5. So what number am I going to plug in for x? Awesome. So now I'm going to have f of 5 equals 5 plus 7. Jesse, what would my final answer be? There you go. 12. We just plugged in a 5. We added the numbers together. Boom. That was pretty doable. Wouldn't you say so, Jesse? Yes, it's not that bad. It just looks really scary. Okay, so Monty, after seeing Jesse go through that example, can you talk me through, if I want to find g of -3, what am I going to do?
To be honest, Miss, I don't know.
So look, when I had f of 5, what did I do with that 5?
So it'd be f of -3
Yeah, so what am I going to do with that -3? Where am I going to put it?
in parentheses.
In parentheses, in place for x, right?
Yeah.
So now, Monty, look with me. If I were to simplify this, don't worry about this side. That's just notation. Looking over here, are you going to multiply or subtract first, according to my order of operations?
Multiply?
Yeah, if we think of PEMDAS, multiplication comes way before subtraction. So I'm going to multiply. So 3 times -3 is going to give me -9. Oh, I forgot my equals. All right. So now I have these two numbers, and now I can subtract them. So -9 minus 8. Does anybody have that answer for me? Or if you have that answer, Monty, that'd be awesome.
-17.
There we go. So Monty, do you understand? We just went through, we plugged in our -3 for any x we saw, and we simplified. Does that make sense, Monty?
Yeah, that makes sense.
Perfect. All right, I'm going to pause in case there are any other questions. Yes, thank you. Nice work. You guys did awesome. All right, I don't see any questions in the chat, and I didn't see any hands raised, so I'm going to go on to frame 7. You guys know I have to kick it up a notch because that's how it is in algebra. We start with our basics, and I'm really not changing the concept at all. I'm still just plugging in these numbers. They're just into a little bit more complicated equations, but nothing we can't handle, right? So, Lexi, in this first problem, look at number 3 with me. And again, we're doing exactly what we did before. Lexi, according to my notation, for number 3, what number am I going to plug in for my variable? What number am I going to plug in for x here?
I'm gonna say 9.
Yeah, I'm just gonna replace my x with a 9. Here we go. So now I have h of 9 equals 2/3. Instead of x, I'm putting a 9 in parentheses minus 1. All right, so cool. Here we go. Now I know you guys are freaking out because we have this fraction. And for some reason, fractions are like arch nemesis in math. I don't know why. I love them, but you guys hate them. Okay, so here's how you deal with a fraction. If you have a regular number multiplied to a fraction, what you do is you take the number, you multiply by the numerator, and then you divide by the denominator. So we do 9 times 2 to give me 18. And then we divide by 3 to give me 6. Now, also remember, you do have a calculator. So, and I don't outlaw that. So if what I just did confused you, you can also plug things into your calculator. Just make sure that if you're plugging in a fraction, you put this, the fraction in parentheses. All right, then I still have this minus 1. So my final answer here, 6 minus 1 would give me 5. Boom. All right, 1 down, 1 more to go. What do you notice that is kind of crazy about this problem? We have a few differences. What has changed with this problem versus the others? What's different? Oh, Sky's just helping us out. Miss G. All right, I don't see any in the chat, so let me point out a few differences for you guys. I have x squared minus x, okay? So this time, my big difference is that I have multiple variables. So all that means is that I'm just going to plug in -4 a couple times. Anywhere we see an x, we're replacing it with -4. The other thing I noticed is that we have an exponent. That for some people, it freaks them out. But again, we're not changing any of the rules. I just made the function a little bit more complicated. So I'm still just going to, anytime I see a -4, replace my x with that value. Now it's going to be super important, especially with negatives and with exponents, that you use parentheses. If you don't use parentheses, you're probably not going to get the right answer. So now I have f of, ooh, Miss Carr, bad notation. F of -4 equals -4 squared minus -4. All right, let's start off with this, because according to my PEMDAS, I don't have anything in parentheses to combine, so I'm going to ignore that. I do, though, this time have exponents. So I'm going to start with my exponent here. -4 times -4. What would that give me? Somebody give me that value. It's -4 squared, which is just -4 times -4. Somebody give me that number. What would -4 squared be? Remember, you all have calculators. You are welcome to use them if mental math is not your strong.
-16.
Ah, Monty, you are so close. I'm actually really glad you answered that way. It's actually going to be +16, because if you think about it, we're doing -4 times -4. So it's like a negative times a negative. Does that make sense? Yeah, just the 2 negatives. So you made a mistake that a lot of people make. So I'm glad we did that. All right. Then I see this double negative. So I'm going to change that one to a positive. So now I have f of -4. I can combine these at the very end. I'm going to add them together and I get 20. Woohoo. All right. I'm going to pause in case there are any questions or concerns, because you guys are going to do one more round of examples here. One more round, and you're going to try them yourself, and they're a little bit trickier. So I want to make sure you're ready. If you have any questions, now is the time. You can throw it in the chat or raise your hand. Give you like 10 more seconds just in case. Did we just have a revelation, Jesse? I missed the oh. What happened to the 2/3? Great question. Okay, so here, Marcus, I multiplied 2/3 times 9. Now, if you have a calculator readily available, you can type in 2/3 times 9. But here's how we deal with fractions. I take the big number and I multiply it by the top. Then I divide by the bottom. So here I did 9 times 2, which would give me 18. And then 18 divided by 3 would give me 6. Does that make sense, Marcus? Awesome. And then, yep, Jesse, if I have 2 negatives right in a row, just like I did here, I change that to a positive. Absolutely. The big thing with negatives, make sure that when you're plugging things in, if you type this into your calculator, you type this in exactly as is with parentheses. If you forget these parentheses, you're going to get negative 16 instead of positive 16, and that will give you a different answer than what we got. You don't want that. All good questions. Thank you guys for asking. All right, then I'm going to move on to frame 8. I know some of these are trickier, but I think you guys can handle it. I want you to pick 2 and try 2 for me. Now, I'm not asking for perfection because these are trickier, but I want you to try regardless. And then I am going to call on a couple people. So if you just need to be ready to walk me through your process, even if you're not 100% sure of the answer, again, that's okay. This is all a learning process, all right? So, here we go. I'm going to give you guys about a minute here. I want you to try 2 of them. I don't care which 2 you choose. Yeah, sorry, my chat is blowing up today. All right, you can see I put 2 names at the top of my screen. I really haven't checked my chat, to be honest with you. I'll check it after class. I have 2 names at the top of my screen, Lexi and Marcus. You are my chosen 2. I don't care which problem you try, but you can tell me which problem you want to try, and then if you could unmute and kind of walk me through the process, that would be awesome. If not, at the very least, go through our chat. But I really want to hear from Lexi and Marcus today. So let's start with Lexi. Lexi, which number did you do? And if you could unmute and kind of walk me through what to do, that'd be awesome.
I started 5, but I didn't finish.
That's okay. What did you start to do in number 5?
I looked at the problem and then I put F and then 5 in parentheses.
Uh-huh.
And then I got kind of confused right there. I was going to put negative x to the 2nd power.
Okay. Now, remember, when we had f of x, we have an x in our equation. Now I want f of 5. So what am I going to put in place of x now, Lexi?
5.
5. So I'm going to rewrite this, Lexi, but everywhere I see an x, I'm going to put a 5 in its place. Are you following me?
Yeah.
Okay, so when you have a number here, you're not going to have any more x's. Those are gone. Right? Now, Lexi, looking at our order of operations, so let me write that at the top of our screen so you can reference. What do you think I would do next?
Exponent.
Exponent, yeah. So here I have 5 squared. Now that negative's in front, so I'm going to leave that alone. And 5 squared, what's 5 times 5?
25.
25. Look at you. You're killing it. All right. So I'm one step closer. What do you think I would do next according to my order of operations? I've gone through this.
Multiplication?
Do you see anything we can multiply?
No.
Oh, look again.
Oh, yeah. 6 and 5.
6 and 5. Off the top of your head, do you know what 6 times 5 is?
30.
There you go. So I got that. I am almost done, Lexi. I'll finish this off for you. So now I got negative 25 plus 30 minus 4. Negative 25 plus 30, that's my next thing I would do. I've made it all the way through to addition. Negative 25 plus 30, that's going to give me 5. Oh, I'm running out of room. 5, and then I still have minus 4. 5 minus 4, that's going to give me 1. So I have f of 5 equals 1, and I have my final answer. Now, Marcus, I think you lucked out today just because we are about, no, we have a couple more minutes. Never mind, I lied. Ha, ha, ha. Sorry, Marcus, you do get to go after all. So I have f of 5 equals 1. Awesome. Good job, Lexi. Thank you for helping. Yes, thank you, Jesse. Marcus, you got one more for me. So, Marcus, which number do you want to do? And if you could unmute, that'd be awesome. You want to try number 6? Ooh, I like it. We're going for the fraction. So if you could unmute, Marcus, what am I going to do in number 6? Marcus? Yeah, we have to put, be careful, it's negative 8. So I'm going to put negative 8 in parentheses. So anywhere I see an X, Marcus, I'm going to put negative 8. So here we go. I got g of negative 8 equals that. I've just replaced my X with my negative 8. Now, Marcus, according to my order of operations, what am I going to deal with first? What am I going to simplify first? Yeah, I'm going to deal with that fraction because that means multiplying. We didn't have any parentheses. We didn't have any exponents, but I do have this multiplication here. So I'm curious, did you get that? When you multiplied those together, did you get that? What did you get? I'm curious if you got it right. Let's see. It's okay if you got it wrong. You asked about the fraction before. So, oh my gosh, you're so close. It's actually positive 4, Marcus, because we have a negative times a negative. But you were so close. That's awesome. So here what Marcus did, he did negative 8 times negative 1, which would give you positive 8, and then divided by 2, which would give you 4. Good. Yeah, you guys are killing it. Then I still have a plus 9. So at the end, Marcus, what would my final answer be? There we go. Boom. All right. You guys are awesome. You really killed it today. I'm going to stop my recording here.